Welcome to Dark 10. Today, we're going to go over 10 mind-blowing theories that could be true. Make sure to watch until number 1, because it's one of the most amazing theories I've ever seen. As much as we'd like to believe that our combined knowledge has unlocked most of the universe's mysteries, we only have a sliver of the information required to properly comprehend it all, and it's a tenuous hold at best. However, every now and then, a new hypothesis emerges that utterly overturns what we thought we understood and leads us down a new path that just could hold the answer to all of our unresolved concerns. These theories frequently express ideas that are too abstract or far-fetched to be accepted by the larger scientific community at the time, but as more discoveries are made and certain puzzle pieces fall into place over time, even the most outlandish theories are sometimes proven to be correct all along. While none of the theories we give here have been definitively proven, they haven't been completely eliminated either. So, why don't you determine for yourself which of these mind-blowing scientific hypotheses has the most chance of succeeding? Number 10. The ekpyrotic universe theory. The ekpyrotic universe idea, which is an alternative to the widely recognized Big Bang theory, proposes that, unlike the Big Bang, which purportedly began with a singularity, our world is actually two universes that collided. This impact is supposed to have had the effect of resetting our universe, which then began expanding again, much like the Big Bang. However, rather than infinitely expanding forever, the theory predicts that the universe will eventually contract, resulting in the Big Crunch, as some astrophysicists refer to it. Then, due to all of the speed and energy involved in the Big Crunch, another massive collision occurs, causing the cosmos to be reset, allowing the cycle to continue indefinitely. Number 9. The existence of white holes. Everyone is familiar with black holes and how their enormous gravity suffocates everything in their path, even light. What about white holes though? They're the polar opposite of a black hole in that they spit things out rather than sucking it in. However, because scientists have never seen one, perhaps because they would only exist in exceedingly hypothetical scenarios, it's uncertain if a white hole would act like the tail end of a black hole, a wormhole, or something else different. If matter was sucked into a black hole by a white hole, that matter would have to avoid merging with the singularity and be maintained in some way. Because all of the black holes we've seen have an event horizon that prohibits us from seeing them directly, we don't know exactly what happens to stuff that gets sucked into one. We can only estimate the positions of black holes in our universe by seeing the gravitational impact they have on the objects in their vicinity. That means that if we ever intend to prove the existence of white holes in the future, we may have to rethink our knowledge of physics, which would be a difficult task. Number 8. The Fermi Paradox. The Fermi Paradox, proposed by physicists Enrico Fermi and Michael H. Hart, contends that if the theory right and there are millions of sentient life forms in our own Milky Way galaxy, then we should have picked up a signal from at least one of them by now. The Great Silence is the name given to this debate. Over the years, a variety of intriguing theories have emerged to explain the Great Silence, the most intriguing and imaginative of which suggests that we're all living out our lives in a matrix-like computer simulation. Number 7. The simulation theory. According to this hypothesis, we are all trapped in a computer simulation constructed by an alien culture in a distant galaxy. While it may sound like something out of a science fiction movie, there are notable scientists and physicists who not only believe the simulation theory is possible, but are also working on studies to prove it. A group of German physicists, in particular, is attempting to program their own replica of our cosmos. Surprisingly, theoretical physicist S. James Gates' latest string theory discovery adds to the idea's believability. Gate discovered what amounts to computer code buried deep within the equations that explain our cosmos. And it's not just any code, it's a self-dual linear binary error-correcting block code, which is incredibly rare. As a result, it appears that error-correcting ones and zeros are entrenched in our universe's quantum core. Wake up, Neo! The Matrix is on your tail. Number 6. The universe is a hologram. This hypothesis proposes that the universe we see is nothing more than a hologram formed by the universe itself, rather than a complex computer simulation. When we look up at the night sky, the faraway stars and galaxies we see are more like an image projected on a wall, according to the theory. When stripped down to the most fundamental of energy scales, this holographic concept could explain why the cosmos appears frail. Keep in mind that a holographic picture is created when a laser beam covers an item, and then a second laser beam leaps off the reflective surface of the first. The image is then illuminated by another light source to create the holograph. If differences in gravitational waves are created by different patterns of light, it is expected that this holographic picture generation process will be simulated. And if this idea is ever confirmed to be right, it will force us to rethink a lot of what we think we know about the cosmos. Number 5. The heat death of the universe. This idea is based on the second law of thermodynamics, which states that if the universe is infinite, then it must also be endlessly ancient. To put it another way, if a star is 1 million light-years away, it can only be there if the universe is at least 1 million years old, assuming the speed of light is constant. As a result, heat death in an endlessly old cosmos implies that the entire universe will ultimately reach the same uniform temperature, at which time the universe will become stationary. However, this theory would only make sense if the rate of expansion of the cosmos has always been constant. Other hypotheses, such as cosmic inflation, would be in direct opposition with this. Number 4. Observing dark energy is an act of murder. Lawrence Krauss, a theoretical physicist, once said that every time we look at dark energy, we're murdering the cosmos. Dark energy, according to astrophysicists, accounts for roughly 70% of all energy in the cosmos and is responsible for many of the inexplicable anomalies observed in deep space. According to Krauss, the Big Bang began when an unusually high energy with gravity-repelling qualities decayed into zero energy, and the process of transitioning from a false vacuum to an ordinary vacuum resulted in the birth of our universe. In quantum physics, the quantum Zeno effect states that if an unstable object is examined on a frequent basis, it will never decay. According to Krauss, if dark energy is continuously observed, we are maintaining its instability and reducing the universe's lifespan by forcing it back to the state when it was a false vacuum. But, with so many of our universe's puzzles pointing to dark energy as the key to solving them, you can bet astronomers and physicists aren't going to stop looking into it anytime soon. Let's hope that consequences are minor. Number 3. The Panspermia Theory. Panspermia is a Greek word that literally means seeds all over. According to the panspermia idea, life's seeds are found across the cosmos and can be spread by natural ways through interstellar space or even intergalactic space. A rising number of people believe that life on Earth began with seeds delivered to our planet by meteorites and comets from the far reaches of the cosmos. The recent finding of several extremophiles, organisms that can survive in severe circumstances previously thought to be inhospitable to life on Earth, has given this notion a lot of credence. It is now established that life as we know it can exist amid extremes of heat, cold, severe radiation, and oxygen deficiency. All possible scenarios for an organism stowing away on an interstellar comet or meteor. Number 2. The Singularity. Ray Kurzweil is a notable futurist who predicts that humanity will experience a technological singularity in the next decades, in which humans will learn to transcend biology and all of its limits, including death. Kurzweil believes that truly intelligent civilizations, such as humans, are destined to evolve into superintelligent, perhaps machine-based entities with exponentially increasing computing powers. The theory is that once we reach this so-called singularity, our technology will have advanced to the point where we will be making revolutionary new achievements on a daily basis. We'll be able to harness the power of our own sun to perform incredible intergalactic feats previously only imagined in science fiction. Cyber mines, Dyson spheres, and teleportation gadgets aren't just plausible in this universe, they're essentially inevitable. Of course, there are many doubters of this hypothesis, including Noam Chomsky, who feels it is nothing more than a science fiction fan's fantasy. Others fear that before we reach the singularity, we will indiscriminately annihilate ourselves. Number 1. Retroactive Precognition. Dr. Daryl J. Bem of Cornell University published Feeling the Future: Experimental Evidence for Anomalous Retroactive Influences on Cognition and Affect in 2011. It covers a series of studies undertaken by Bem in an attempt to detect precognition, knowledge of future events. The evidence Bem obtained led him to conclude that future events could indeed alter a person's cognition in the present, based on the notion that there are anomalous processes of information or energy transfer that are currently unexplained in terms of recognized physical or biological mechanisms. In one study, Bem gathered 1,000 college students and put them through a series of tests to see how well they could intuit random facts. A reverse memory test was used in another study, in which participants were asked to categorize random words that they would later have to commit to memory. Surprisingly, the findings of this test revealed that pupils who made a point of memorizing terms in the future were more likely to recollect them in the present. Subscribe Dark 10 and turn on notifications so you don't miss more videos of creepy, interesting, or scary facts and much more. If you liked this video, check out my other videos. I'm sure you will enjoy them very much as well. Take care.